Hi, welcome back. So, did you manage to find the equation of the line DC? Okay, if not, don't worry. I've done it here and you can go through together. So, remember DC, what do we have on DC? So, D, we have got this point here, D. D is 8, comma negative 1. So, I've put it here, 8, comma negative 1 as the first coordinate. And then C is 4, comma 2. So, I've put it here. This is the 4, comma 2. This is my second coordinate. So going by the formula, m is equal to y2 minus y1. So in this case, I'm going to say my y2 is this, which is the 2 here, minus negative 1, which is minus this is the y1 here, negative 1, divided by, this is the 4, this is the yx2, 4 minus 8 is the x1. So we've got this, and then it's equal to, so how do you go about this? So we say this is 2 minus negative 1, which is 3, divided by 4 minus 8, which is negative 4. And then what we get at the end of it is we get the answer as negative 0.75. Okay, we're getting the same answers here. It's not to say all the points are going to have are going to give the same answers. No, just coincidence in this case. Okay. Now, let's look at something else. Suppose now we're told, okay, suppose we are told find the equation of line. Find the equation of the line. The first one begin with AC. Okay. Suppose we are told find the equation of the line AC. Okay. How do we go about doing this? Okay. So I'm not going to go into the details here. All I'm going to tell you is the equation of a line is generally given by the formula y is equal to given by the formula y is equal to mx plus c. So this is the key equation for finding the equation of a line. What does this entail? What does this tell us? If this was my graph, okay, my y, my x, and suppose this was the line here, okay. So I said this is my y and this is my what? X, over this is the point 0. So I'm talking about this equation here, okay. So if I'm talking about this equation here, what is the meaning of this? Okay, what's the meaning of this? Y is equal to m plus x plus c. What does all this mean? So if you look at this, it simply tells you to say, if you go on this line here, pick any point. If you, for example, pick this point here, try to plot it below here. What is its x? So this is x here. What is its y? Its y will be somewhere here. So if the x and y that you see are basically any line, any point on this, it could be this point, it could be this point, where you plot this against its x and against its y. So if you pick any point along this line, you plug them here as the y, in this case the y, and the x. So I'm talking about this, the x, I mean the y is like this y here for this point, and its x is below here, so that's its x here. And then what is the m here? The m is the gradient. So in this case, do you have the gradient for AC? You got it. So the gradient for this is we found this to be our m. We found it to be negative 0.75. Okay, so which is also 3 over 4 negative. So then, if you want to find the equation, are we able to do that? How do we go about this? Remember, if I can know any x, I mean any y and any x, if I can also know m, which I know, then I can easily find out what is c for this equation. So by the way, c is the point where the line is cutting the y-axis. For example, have you seen this line here? This line here. So this line here is cutting the x-axis at this point here, okay, here. So this is the point that we are referring to as the constant or the c. it's constant because it doesn't change. However, you're going to draw this line. This line is still going to cut on that point here, which is a constant, where x is 0 and this is where it's cutting the y-axis. Now, how do we find this? So let's look at this example here. Find the equation of AC. So what we need to know is we need to know the value of y and the value of x. In this case, since I'm talking about AC, I can pick any of these points. I can pick this point or this point. So in this case, I'm going to pick this point because they are both on this line. So I'll pick this point here, 4,2. Okay, so I'll pick this point here. So if I pick this point 4,2, then it follows that my y is going to be equal to 2 and my x is going to be equal to 4. It's simple. So x comma y. So this is y here, and then x is here. This is the one which I have here. Then do I know the gradient? Yes, I know. It's this one here. So what do I do? Let me now substitute y, m, and x, and then use that to find the value of c. So I'm going to do this. So I'm going to say this is m. So m is, y. So it's y is equal to. So what is y? Y is 2. Y is 4. So the y is 2. So this is 2 is equal to m. So m is negative 3 over 4. And then what is x? X is 4 here. So I'm going to put the 4 here. Okay. And then I'm going to say plus c. So I'm trying to find the value of c which I don't have here. So what do I do? So this is going to be equal to 2 is equal to. So the 4 will cancel the 4. So it becomes negative 3 like this plus, okay, negative 3 plus c. So at this point in time, I can simply move the 3 to come this side. In that case, if the 3 here, which is negative, comes here, it's going to become a positive. So it's going to be like 2 plus 3 is equal to c. So which simply means c is equal to 2 plus 3, which is equal to 5. In this case, we are saying the equation for line AC, its constant is 5, meaning that this line is cutting the x-axis. If you can look at here, it's cutting the x-axis, this point. So this point, if we are told to say what is this point here, this point can be labeled as got a value of 5. That is the constant. So then we can write out the equation for this line and say, remember, it's y is equal to mx plus c. Okay, so in this case, we can say it's going to be, so in this case, we won't substitute now the x and the y. No, we won't substitute the constant and the m. So the equation becomes y is equal to m is equal to negative 3 over 4, and then plus the constant is what? 5. That's the equation. If you want to get rid of the 4 here, we can multiply. You can multiply this side by what? By 4, and also multiply this side by 4. So 4 is this denominator here. So 4 by y becomes 4y is equal to. So this 4 here, this 4 is going to multiply this, to also multiply the 5 here. So 4 by this, you notice that the 4 is going to cancel the 4. We're going to remain with a negative 3. That's what we're trying to do after. And then the next thing is, okay, so there is supposed to be an x here, right? Yeah, so negative 3x. Then the 4 can multiply the 5 here. It becomes 4 times 5 becomes plus 20. So this is the equation, okay? Even if you left it in this format here, like it was doing here, it's still the same thing. Okay, if you want this to look better, you can say, let me have the 3x come this side. Okay, so here it's what? It's negative. So if it comes here, it's going to be positive. So what we are going to do is we are going to say it's 4y, then 3x comes here, it becomes plus 3x is equal to 20. So this is going to be the equation of the line AC. So you can try and follow the same steps and see if you can find the equation of line BD, if you can find the line of the equation of line DC, applying the same things that we have done here. So just to summarize, what you need to know is the equation of a line is given by y is equal to mx plus c, and then what we need to know is find out any point on that line. In that case, I had this line here, at this point here, and then find out what is the gradient of the line. So I had the gradient m here, which I had as 3/4. So the rest of what remains is just substitute y with one of the points here, which is the y coordinate. Substitute x for this. In this case, the 4 here. Substitute the m with the gradient. Use that to find the value of c, which we did here. Then come and plug back into the equation plug back the m and the c. Everything else, the x and y, leave them there. That should be able to allow you to reach the final equation of that line. If you got that, try it out. Try to see if you can work out, equation for BD, equation for DC. Remember, the coordinates of these lines are here, so you can take a snapshot of this and be able to do some computation. So if you try that, well and good, and we're going to see you right in the next video. See you.